Hello. In this video we're going to look at the definitions of the trigonometric functions on a unit circle. So, what you were used to, or introduced to probably, are these definitions for sine, cosine, tangent, cosecant, secant, and cotangent in terms of opposite, hypotenuse, and adjacent. Now, these are what I call freeform. What do I mean by freeform? Well, you could have a triangle in any orientation. It could have been like something like this, right? And then you might have been looking with respect to this angle. And in which case, with respect to this angle, this is the opposite, this is the adjacent, and always across from the right angle is the hypotenuse. But if you'd maybe looked at it relative to this angle, then relative to the beta, this would be the opposite, this would be the adjacent, and this is the hypotenuse. So in that case, and I could take this triangle and just turn it around in any direction, and this is what I mean by freeform. Okay? But once we standardize the right triangle by dropping, for any particular angle, by dropping a perpendicular to the x-axis, now we've standardized things. So what do I mean by that? Well, let's take a look at what happens in each quadrant. Let's suppose I go out a certain rotation in the first quadrant. So there's my angle right there. Well, by definition, I am supposed to create a reference triangle, drop to the x-axis. Here's my right angle. And then my reference angle is right here. It's not here. It's always right here between the angle and the x-axis. So relative to this reference angle, this is the opposite, this is the adjacent, and this is the hypotenuse. But because this is always the angle, you can't have this being the angle like you could have in this freeform, then you will always have this configuration, which means that now the adjacent will always be the x-coordinate, the opposite will always be the y-coordinate, and of course the hypotenuse will always be the radius. Okay? And let's see, does this happen in every coordinate? In every quadrant? Yes. So let's take a look at second quadrant. So if we look in the second quadrant, what happens? All right, so let's suppose I rotate a certain angle, and I'm in the second quadrant. There's my angle right there. But remember, I have to drop a perpendicular to the x-axis to represent that angle. And then my reference angle is this one here. So therefore, relative to this reference angle, this is the opposite, this is the adjacent, and this is the hypotenuse. Okay? But you can see this is the x-coordinate, this is the y-coordinate of this point, right? Just as it was here, over x up y would give me this point. Over x up y would give me the coordinates of this point. So indeed, this is staying the same, where the adjacent is x and the y is the opposite. Let's see if it continues. So here we are in the third quadrant. In the third quadrant, let's say, of course I always start rotation from 0. I rotate, 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 and I'm somewhere here in the third quadrant. Here's my angle. Right, there it is. I drop a perpendicular to the x-axis. My reference angle is this one right here. Relative to this reference angle, this is the opposite, this is the adjacent, and this is the hypotenuse. But this point is also can be referenced by x and y. And indeed, the adjacent is x, and the opposite is y, and the hypotenuse is r. Okay, so far we've stayed consistent. The last check is here for the fourth quadrant. If I rotate all the way into the fourth quadrant like this, there's my angle. I drop perpendicular to the x-axis, and then what I see is that this is my reference angle. Relative to the reference angle, this is opposite, adjacent, and hypotenuse. But I can also say that this point, it has the coordinates over x and down y, and the x is the adjacent, the opposite is the y, hypotenuse is the r. So indeed what we see then is that now for any triangle, right triangle that is on the unit circle and being represented by a reference triangle and reference angle, what we see is that R is the hypotenuse, X is the adjacent, and Y is the opposite. Okay? So what does that mean for us? Well, what it means is we have new definitions that are standardized definitions, standardized on the unit circle. So these were free form, right? But now when they're standardized, we're going to have Y over R, X over R, Y over X. And of course over here, R over Y, R over X, oops, and X over Y. Okay? So, now when R is 1 because you're on the unit circle, then what happens is R is 1 and this just becomes Y, this just becomes X. Okay? This becomes 1 over Y, 1 over X, right? So that you have these definitions when you're on the unit circle specifically. Okay? All right, thanks for listening.